Geographical explanation. Both the photographs show the same place. If you stay near the coast for some time, you'll realize that the sea water is sometimes very close to the coast, figure 3.A, while at other times it is far away from the coast, figure 3.1B. We call these movements of the sea water tides. Barring a few exceptions, all the coasts on the earth experience tides. High and low tides are natural phenomena. Let us try to understand the scientific reason behind these natural events. Tides are movements of sea water occurring daily and regularly. The level of sea water changes after a specific period of time. After every 12 hours and 25 minutes, a cycle of high tide and low tide gets completed. This regularly occurring event appears to be quite simple and natural. However, it is directly related to the sun, the moon, and the earth, and the gravitational and centrifugal forces that interact between them. Try this. Keep a small stone or a chalk piece on your notebook and move the notebook from left to right with some force. Take water in small container which has a handle. See what happens if the container is whirled around with force. Fill the mixer jars with water and switch on the mixer. Observe. Do this under the supervision of parents. Observe a fan and a slingshot while they are moving. Take half a glass of water. Slowly move the glass in one direction in circular fashion. Observe what happens to the water. Observe what happens if you whirl a key ring around a finger. Geographical explanation. In all the above activities, the effect of the centrifugal force is visible. The centrifugal force acts in the direction opposite to the gravitational force. Centrifugal means going away from the center. You must have experienced it too. At the local fairs, if you sit in a Ferris wheel, your seat spins and leans outward away from the wheel. This also is an effect of centrifugal force. Centrifugal and gravitational force. Due to its rotation, the earth gets a type of power or force. This force works away from the center. It is called centrifugal force. See figure 3.5. Due to this force, any object on the earth would be thrown into the space. However, the gravitational force is working towards the center of the earth at the same time. This force is many times greater than the centrifugal force. Hence, any object on the surface of the earth remains at the place where it exists. Tides. The following factors are responsible for the occurrence of tides. The gravitational pull of the moon and the sun, as well as that of the earth. Revolution of the earth around the sun and the indirect revolution of the moon around the sun. Centrifugal force generated due to the rotation of the earth. The moon is closer to the earth than the sun. Hence, its gravitational force becomes more effective than that of the sun. Tides occur due to the relative positions of the moon, the sun, and the earth. A place on the earth located at the opposite point of the place experiencing high or low tide also experiences high or low tide respectively at the same time. This is a result of the centrifugal force. See figure 3.6 and try to understand the locations of high and low tides on the earth. When there is high tide at 0 degrees meridian, the 180 degrees meridian also experiences high tide. The meridians that are at right angles to those having high tide will experience low tide at the same time. If it is high tide at 0 degrees and 180 degrees meridians, then at which meridians will low tides occur? Types of tides. As the timing of the tide varies every day, the range of the tide also keeps on changing. Generally, the highest high tide occurs on full moon and new moon days, whereas on the days of the first and the third quarter, the high tide is at its minimum. Spring tides and neap tides are the two types of tides. Spring tide. On new moon and full moon days, the gravitational pull of the sun and the moon act in the same direction. Due to this, the total pull increases. Hence, the tide on these days is much higher than the average high tide. This is known as spring tide. See figure 3.7. As the bulge at the high tide is greater, the water at low tide recedes much more. The water level during spring tide is higher than the average high tides and lower than the average.